It's up to 12 pounds.
How?
It's as big as possible.
Oh.
Is the goal.
He's barely 12 pounds. How old is he?
It's 5 months today.
My cousin was born at 12 pounds.
Jeez.
5 months today.
How old's your baby?
She just turned 4 months.
Wait, what happens? Baby is on the day?
By a month.
Not a month. It's only a week or two.
No, like 3 weeks.
Like a month. It's round.
When's his birthday? Her birthday?
She just turned 4 months like a week ago.
What's her birthday?
The 18th of June.
Oh, 18th.
Yeah, it's like 3 weeks.
Did you push play already?
Yeah.
Oh.
I can stop him and make a new video.
Yeah, whatever.
Make him wait. No,
Eh?
make him waste the time.
So it makes it look like it's a long video and we do nothing. I hate that.
I know, that'd be so funny.
I watched that freaking 40
Can
one.
we just like...
Just like chill. No, let's
Okay,
go.
so they just heard us say that.
No, like when we're done, like just...
Graphs of the, what's this?
Prime.
What's it, okay, what's it mean?
Derivative.
Derivative? What's the derivative
Slope
slope
of at
of-
1 point.
at 1 point? Okay, so now we're going to graph functions and then their derivatives. Alright,
You probably have the notes right there.
No,
so I just printed this. So that we can look at it. This is page 101 in your book. Here's a graph of a function. Now the graph of the derivative, this is kind of weird, is the graph of all of the slopes at every point. So, look at, here's our original function. If you did the graph of this function, if you looked at this point, the slope right here at that point would be 4, because it's pretty steep, right?
Yeah.
And then they have the slopes labeled here. The slope here is 1, because look, it's not as steep. And then right here at the vertex, the slope is 0, kind of like your homework problem.
Yeah.
Yeah, that's always will happen. Slope
What's up
at a
with your
vertex.
pen?
I broke it. This is like that's gonna go. So then we got the slope is -1. The slope's still -1. The slope back to 0, right? So those are just like key points that they've labeled. Here's the graph of the derivative of this, right? This is y. This would be y prime. Notice when x is 0, what is y prime? 4, because at this point in the original, the slope was 4. So this is, the y-axis is the slopes at all of these points. So when x is 1, our slope was 1, right? Or I guess it was a little over 1. The slope was 1. So right here, y is 1. Because this is basically like slope. If you could think, they wrote it, slope. So this is all the slopes. So this kind of makes sense? When
Yeah.
x is 2, the slope was 0, so when x is 2, we hit 0. So the graph of the derivative of this, it becomes a parabola, actually. And you're going to start seeing lots of connections between graphs and their derivatives. Derivative graphs. But this is just your first one you've seen, so. Right? Slope, x is 3, slope is -1, so we got -1. And then it goes, x is 5, slope is still -1. Does that kind of make sense?
Yeah.
That's just how derivative graphs work. So if you have a graph, we'll just do a second one here real quick. Let's say, give you an easy one. Here. Ready? 2, 1. There's my original graph. What would the graph of the derivative look like? Well, let's just go point by point. Right here, what's the slope at that
0.
point?
0. 1, 2.
2.
2. The slope is 2. Isn't this a line?
Yeah.
Yeah.
Isn't the slope always the same everywhere?
Oh,
So whether I'm here, or here, or here, or here, isn't the slope 2? So the graph of the derivative then will be what? It'll be a horizontal line at 2. That is the derivative of that. These is the slope, right? These. That's it, yeah, that's it. I mean, that is it. Of course, it's getting harder, but that's the whole idea. The graph of the derivative is just the graph at the slope of every point. Okay? Let's go back to this one. We're going to do this problem out of the book. They're going to ask some questions. We're going to talk about the questions. Back to follow along on page 102. It says, suppose that this function represents the depth of water in a ditch alongside a dirt road as a function of time. So, right, you're rolling into Warden, there's ditches on either side. This is the depth of the water in that ditch, right? Over time. So time in days. So this would be days. This would be inches of water. Depth in inches of the water in the ditch. So like day 0, whenever the first day you drive by, there was 1 inch. Then the next day it was up to like 4 inches, right? I'm looking at just the y-axis. I'm not looking at the slopes yet. That's all. Do you understand what we're looking at here? Mm-hmm. So as the days go on, the water went up, and then the water fell, and then the water started to go back up again, right? Good. Said, how would you answer the following questions? Number 1, what does the graph of this represent? Meaning, what units would go here? This would still be days, but what units would go here?
The slope.
So I would write slope. Now I want units in the context of this problem. What is this? What are we looking at? On day 0, we had 4 what? On day 1, we had like 1.2 what? What is that? What is
The water.
0.8 inches of water.
inches? Isn't this inches of water? On day 0, we had 1 inch of water. On day 0, we had 4 inches of water. That doesn't make sense. This is not this. Remember, this is the derivative, which is the slope, right? What does slope represent on this graph? Like if I look right here, the slope is 4. What does that mean? Yeah. How much it isn't slope? Why are you laughing? Just because Pedro's smart now? Told you he's a beast. He's coming for you. He's going to beat you. How much it increased? So right here, the slope is 4. That means that at that point in time, it was increasing. The water was rising at 4 inches per day. Does that make sense?
Yeah.
Right here, on day 2, when it's 0, the slope is 0, right? Slope is always this per this, right? Is it always y divided by x? For example, back when we were doing a, like if this was distance in miles, and this was time in hours, and you got a graph, who cares, whatever. And I said, what does the slope of this line represent? What would you say? The increase
into
change
the distance of the
divided by the increase in time, which would give you the slope. So your units of that slope would be, okay, let's do a line. If I drew a line and I said, here's 1, 2, 3, here's a 40, 80, 120. What's the slope of that line? It's a horrible picture, no? 40? 40. So what are the units of that?
Miles per hour.
Miles per hour, right? It's always just
Didn't you
this
say that?
per
Yeah,
this.
Pedro said that all the time.
Pedro said that?
Yeah.
Okay.
Of course he did.
I didn't hear him.
Beast.
He's
Yes.
coming back for you.
Miles per hour. The slope is units. This unit divided by this unit, right? Because we divide the numbers, we can also divide the units. You know, dimensional analysis. You know that? Well,
Yeah.
if you're in physics, I don't know. This divided by this, miles per hour. That's the units of the slope, right? That's the meaning of the slope. So in this one, it's inches per day. So like at day 2, the inches per day of the water, it was 0. It stopped stopped increasing or decreasing, it just stayed the same, right, for that day? So that's why you see over here, 0. So what are our units here? Inches per day. This is inches over days. This is inches or inches per day. That would be the units of that graph. Okay, so now you're going to have to remember that to answer the next questions. It says, describe as carefully as you can what happened to the water in the ditch over the course of the 7-day period. Who wants to give that a shot?
It lost water and then it gained water.
What is it?
No, that is incorrect. It said, describe as carefully as you can what happened to the water in the ditch over the course of
What
the
did he say?
7-day period. He said it lost water and then it gained water.
If you-
And I said, that is incorrect.
Write it down.
What happened first? It gained water. Look at this one. Did the water level just rise? This is the easiest one to interpret because this is the one you've seen all your life. The water level went up, and then it went down. And then it started to go back up again, right? If you look at this one, it's not as easy. You have to think, what is this one actually telling you?
It started up.
Huh?
It started up.
What started up?
The inches of.
Not the level of the water. This is not the water level. What
The
is
pressure. I don't know. I don't know we doing that. Can you just tell us?
It's inches per day. This is how it's changing. So the rate at which the water was rising started high, right? The rate at which it was rising, so it's getting deeper and deeper and deeper pretty fast.
Oh, so it's increasing and then it's
But then as
increasing
this goes
slower.
down, the water level is still rising right here. But it's just not rising as fast. It's slowing down, it's slowing down. Then what happens here, the water level doesn't move. The inches per day is 0. The water level stays the same for just that period of time right there. Once this goes negative, negative inches per day means what? What's happening now?
It's losing water.
The water level starts going back down. Water level is going down, stays the same, and once I go positive again, the water level starts increasing. So this is the way the water level is changing. This is the actual level of the water. Blow your mind, Tanya?
Yeah.
Yeah? Okay, Tanya, you're going to answer this question.
No.
Can you describe the weather during the 7 days? When was it the wettest? When was it the driest? So we're just going to assume that the only thing that made the water level change was rain, and the only thing that made the water level, raise was rain. The only thing that made the water level drop was evaporation. So no one was pouring water in or pumping it out.
So during the
So-
7 days, it began, it was raining at the beginning.
When was it raining the hardest?
Day 2.
The first
When it got up
day.
to 4.
The first
Oh,
day.
whoa.
I don't know.
Day 0 or day 1?
Day 1.
Day
Day
1.
Day 1 was raining the
No,
hardest?
no, day 0. Wait. Day 0.
Day 1.
Day 0.
No.
Wait, is there day 0? What? I don't know.
Yeah, day 0 is just like the
That
first day you
day.
looked at it. That's
Day 0
day
was
0.
raining the hardest.
Who thinks it's day 0 raining the hardest?
We got you, don't
I'm
worry.
afraid to put my hand on it.
Who thinks day 1 was raining the hardest? No one?
I don't know.
Zoe, what do you think? When was it raining the hardest?
Well, once it got to day 1 is when the slope started increasing, so I don't know.
The slope is 4 here, the slope is only 1 here.
It's day 0.
Isn't the slope getting smaller?
Where's my hand?
It is day 0.
Yeah.
The inches per day, that's the rate at which it's rising. The inches per day was the highest at day 0. That was when it was raining the hardest. And then it kind of let up a little bit. When did it stop raining?
Like day 1 during
Half the day.
I don't know, because it's
Day
1 and
2.
something.
Day
Day
2.
Day 2.
Still
Day
raining.
2.
Because the inches per day is at
It
0.
stopped, yeah.
It stopped rising and it flattened out. It stopped raining. What happened between day 2 and day 6?
Evaporation.
Yeah, just slowly evaporating. Yeah. Which day was the hottest?
Day 4.
Day 4.
I think it's day 4.
Yeah, 'cause it's the least amount of water.
Yeah.
That's where the inches per day is the most negative. That's when the most is evaporating, right? Which is hard to tell on this graph. This graph isn't useful
Yeah.
for that, really, is it? But on this graph, you just look at like, oh, the inches per day was way low here. So that's when it was the hottest. That's when it was. Okay, I think I almost did all these. How does the graph of the derivative help in finding whether was hottest or wettest? They say wettest or driest. Hottest or
The lowest is the driest and the highest
Yeah.
is the wettest.
This is the driest or the hottest, and this is the wettest when it was raining the most, right? Good. Let's see. Interpret the significance of point C in terms of the water in the ditch. Oh, we talked about that, I think. Why is point C significant? All they're asking is, that's when it stopped changing.
Yeah.
It's just,
It stayed the same.
it just stayed the same for that instant in time, yeah. How does this, it says, how does the significance of the point C prime reflect that in terms of rate of change? It's just saying the slope was 0 at that point. Yeah, that's not a good question. I think that's it. Construct your own real-world scenario for this. So we will look at a lot of graphs and their derivatives, and you'll have to like answer questions like this about what's happening in each one. And it's because you've never looked at anything like this before. You've always just seen, oh, it goes up, it goes down, right? That's how graphs have always been. Now graphs of derivatives are the rate at which things are changing. You could talk, a great example of this, we'll do a lot of position, velocity, and acceleration. Physics people in the house, that's right, not very many, it's just you, huh? Position, velocity, and acceleration are much easier to understand if you know what a derivative is. You can look at the graphs of the derivatives. So, that'll be later though. Okay.
Are we going to do that for our homework?
What?
Are we going to do that for the homework?
Do what?
I should give us the graph and then
No.
we have to graph. the
No,
homework.
but that's the beginning of just understanding what a derivative graph is. That took 17 minutes? Okay, that's the beginning. We're going to sketch a graph.
No, just like them. No one's actually watching.
There we go. We're going to graph a function with the following properties.
It's the only one I can see actually watching.
So we're going to graph a function that has f of 0 equal to 0. It'll also have the derivative graph will look like this. I'll give you the derivative graph. So what I'm going to do, I'm going to give you this. I'm going to give you the graph of the derivative. And then I'm also going to give you, well, it just says f is continuous for all of x. But that's so here's the graph of the derivative. And then you're going to draw the graph of the original. So this is y prime and x. These are just going by ones, nothing tricky here. So there's the derivative graph. Oh, and then the third stipulation was that f of x is continuous. So you probably have no idea where to start. That's okay. You might know where to start. You know where to start, Brenda? We're going to draw a graph that has these conditions. That's the derivative. F of 0 is 0 and f of x is continuous. So we're going to graph f of x here. Mine's crooked. Who knows where should we start? We need a point. Do you know a point that we should start?
I'm
Two,
guessing
one.
is it's probably
One, two.
2x.
1, 2.
For the-
What's that
guess?
saying? Is it this slope of 2? Is that what
Oh, okay, yeah. It is a slope. That means slope of 2, right?
Yeah.
Yeah.
What's that mean?
Slope of negative 2.
Negative 1.
Negative
Oh,
1.
negative 1, I mean.
But where are we going to start?
There's a
0.
Yeah. Doesn't it tell you f of 0 is 0? So what's that tell you?
Start at 0.
When x is 0, y is 0,
yeah.
right? So boom, we'll start right here. You want to go left first or right first? So we know our graph, our function is going to go through that point. So to the left of 0, what happens? Now we're going to use this.
the slope of 1, but it has an open circle.
That's what we're just looking to the left of 0 right now, so we're not even worried about that yet. So what's happening over here?
It's a slope of 1, so it's a line.
Slope of 1?
Or negative 1.
Doesn't this say that this is the graph of the derivative, right?
Yeah.
Doesn't this tell us that the slope is negative 1
Yeah.
forever? So what's it going to look like over here?
Down 1 or back 1,
Negative x, right?
Yeah, it's going to be like negative x. It's going to just be,
Oh, the
Back
back,
one,
1,
up
up
one.
1.
right? Negative over a positive, right? Something like that. Forever. Want to try to finish? See if you can finish it.
Yeah. Just didn't,
It just didn't go down to negative.
You don't know? What happens to the right?
Keep going without.
Doesn't the slope continue to be negative 1 until we hit 1?
Yeah.
Yeah.
So we'll just keep going. Till here. And then this part is weird, I wouldn't expect you to know. All of a sudden, what happens?
Open circle and it changes.
But f of x is continuous, so we're not going to have an open circle. But I understand why you would think that, because there's an open circle here. But the slope all of a sudden just jumps up to 2, right? So all that happens then is right here at this point, we're going to go up 2 over 1. So it almost looks like a weird absolute value graph. The reason there are open circles here is the derivative at a corner like that is undefined. The derivative at the vertex of a parabola is 0, but the derivative at like an absolute value graph where it's a sharp corner is undefined. So they have that, but that'll come later. So
Wait, why do you go up 2 over 1?
because right here, now as we're moving to the left, or to the right from the left, doesn't, once we hit x equals 1, doesn't the derivative jump up to 2?
Yeah.
Or the slope jump up to 2? Same
So
thing.
if it jumps up the slope like that, then you go.
So we had a slope of negative 1, negative 1, negative 1, negative 1. Now boom, now we have a slope of positive 2, positive 2, positive 2, positive 2. Cool, makes sense. So remember, slope of the derivative, the graph of the derivative is just the graph of all the slopes of the original. The most of what you're going to have to do in your homework, you're not necessarily going to have to draw, like the first 4 are matching. It gives you a bunch of graphs of derivatives, and you got to match them together. So for example, let's say, do one more real quick to show you.
I figured out the
I'm like, your noses.
These are hard to draw.
Yeah, I know what you mean.
Can you tell me what the graph of the derivative of that would look like? Just thinking. I look for key points when I do these. What do you think a key point would be?
When it hits the x-axis.
Stops rising and goes down.
When it stops rising and goes down, why? What's the slope at that point?
0.
0. Does that make sense? So like right here, I know my drawing's bad. Isn't the slope 0? So on the graph of the derivative, what will happen? Where will a point? You'll have an x-intercept, won't you?
Yeah.
So right there, we'll have a point. Like I said, you're not actually going to have to do this, but you're going to have to recognize them to match. And then right here, again, isn't the slope 0? So when x is 1, we would have a point at 0.
Same with negative 1.
Is that supposed
At
to be?
negative 1, no, the slope is not 0. What?
Is that
Oh,
supposed
because
to be
it doesn't
touching?
change, it keeps going. Okay, I get it.
What's supposed to be touching?
That
That.
middle loop.
Here?
Yeah. The one.
That's supposed to be touching that? No. It's above it.
So no matter what, at those points, they're gonna be.
The slope
0.
is 0. Remember, this is slope. So, yeah, this is not, you're not going to have an x-intercept at
It
negative
keeps
1,
going.
because look at the slope. The slope is big.
4.
So I don't know what it is, who knows? But it's like, it's really big, and it's getting smaller and smaller and smaller until it hits 0.
Supposed to be
So,
coming from the
It's
top.
going to come down like that, somehow. It's really big, and it's getting smaller and smaller and smaller. And then it's going to hit 0, and it's going to get negative and negative and negative. Well, these are weird. This is advanced. There's a point of inflection. That's too much for you right now. I gotta go basic here. So it's gonna get smaller and smaller and smaller for a while, and then it's gonna turn around and get less small and less small. We might as well
This is a
talk
bad
about it.
example.
Let's zoom in right here.
Oh,
You don't have to draw it.
Whoa.
Can you see what's happening to the slope? If you take your pen and follow it, it's getting more and more negative, more and more negative, more and more negative. And then once you hit the middle, then all of a sudden, doesn't it become less and less negative and less and less negative and less and less negative until it goes back to 0?
Yeah.
Yeah, that's weird, huh? It's negative, the slope is negative the whole time, but it's getting more and more negative and more negative. Stops for a minute and then gets less and less negative. So what that looks like in the graph, it gets more and more negative, and then it's going to flatten out and get less and less negative and less negative. It's called a point of inflection, just for future reference, for chapter 5 reference. That's point of inflection. You'll see that. And then, after here, it's going to get more and more positive forever. So it's going to get more and more positive forever. We're going to have a
Oh,
problem.
that's terrible.
And then we could do the graph of the derivative of that and have a double derivative. That's when it gets fun.
I go to the restroom. What if you
But-
done?
Yeah, we'll see.
Oh, look at the time.
Oh, look at the time. All right. I was going to get on a roll here. We could have done a graph of that, derivative of that, and then the derivative of that one. You could just keep going, derivative. But no, it gets cool when you do it. If you draw them all, we'll do it too. We'll draw them all on the same piece of paper, all right over each other, and you'll see a connection between all of them.
Are we gonna have homework on this
That's a
yet?
magical thing. Yeah. 3.1, number 13 through 16. Those are the matching a graph of this derivative. 18 is kind of like yesterday.
So you said I'm gonna go restroom.
22, you have to draw. Oh, so 22, you do have to draw it. It's just like we did. It's almost the same. We'll hold off on the rest. I have more. Hold on, one thing on 18. On this one, the directions say find the derivative of the function y equals 2x squared minus 13x plus 5 and use it to find the equation of the line tangent to the curve at x equals 3. Alright? So that's like yesterday.
Like number 5.
Like number-
But it's not, because it says find the derivative and then use it to find the equation of the line tangent to the curve at x equals
So
3.
you do both.
So I don't want you to do 3 whatever, 3 plus h whatever, and then just go straight and get your slope. I want you to do x whatever, x plus h whatever. Use it to get an equation,
And
and then plug in 3.
in the equation you get,
Yeah.
which is, yeah.
Make sense?
on that one, number 7?
Yeah.
So in 18, yeah, you have 2x squared, so you have this, you have 2x squared minus 13x plus 5. You're gonna do x, comma, what would be this one?
I have to pee so
2x squared minus 13x plus 5. And then you're gonna do x plus h, 2 times x plus h squared minus 13 times x plus h plus 5. Change the y over change in x, limit as h approaches 0. Pick your answer, plug in 3 for
Plug in
x.
3 and then that's the slope.
That's your slope.
Do you want me to turn this off?
Bye.
Oh, yeah.
Bye.
What?